Alright, this is a practice quiz. It is a nice little snapshot of the different types of basic logarithm problems on which we've been working for the last week or so. Well, 10,000 is 10 to the fourth power. So this is the same thing as having log of 1 over 10 to the fourth power. You can count the zeros and it'll be 10 to that power. Or you can use your chart. Mm-hmm. 10 to the fourth power is 10,000. Anyway, so, but this would be the same thing as log of 10 to the negative 4 powers, because that would drop you down to the denominator like this. Now, please remember that log with no visible base, like this is base 6, this is base 9, yet this is showing no base. That means this is an invisible base 10. And if you have log base 10 and a base 10, those are going to wind up undoing each other, and you're just going to have negative 4 as your answer. Okay, so negative 4 is the final answer for number 1. Alright, number 2. 216. I'm pretty sure that is 6 to the third power. Let's take a look. 6 to the third power is 216. Now, there's more than one way to do this problem, but remember I suggested to you that when you have 1 over a number like this, ignore that 1 for a second and ask yourself, 6 to what power? Start with this question. 6 to what power is equal to 216? Okay, we just said that would be the third power. Okay, but since it's really 1 over 216, then that means it would need to be the negative 3 power, because that would drop you down to the denominator. Alright, so the answer for number 2 is negative 3. Okay, this is pretty much the same thing. As we ask ourselves, 9 to the what power is going to give you 81? Well, that's just 2, just plain and simple. 9 squared is 81, so the answer is 2. Alright, this one's a little weird because it has this x up here messing us up. So I'm going to do it this way. Okay, so this is log base 3. Now, 81, you might, off the top of your head, you're probably thinking 81 is 9 squared. Okay, but 81 is also 3 to the fourth power. Alright, and it's that second fact that we're going to use right now. Alright, 81 is 3 to the fourth power. And, so you can find that off your chart here. Okay, so there's your 81, 3 to the fourth power, and there's your 81. So 81 shows up twice on this chart, but this is the one we need. Because if I write this 81 as 3 to the fourth power, then I've got this x sitting here, right? But this log base 3 and base 3 undo each other, and I'm left with just the 4x. So that is the easiest thing to do. Okay. Now, similarly on this one, natural log. When they give us a natural log with no, they don't show the base, but it's always an invisible base e. So what we have is log base e and a base e. They undo each other. And so we're just left with 5. Okay, so that is it so far. Alright, so number 6. Okay, again, log of a number. That means it's an invisible base 10. Okay, so you should be asking yourself, 10 to what power is going to give me 1000? Well, you see those 3 zeros? That means this is 10 to the third power. So the answer is going to be 3. Alright, if you don't trust my zero rule, just look at your chart. 10 to the third power is 1000. Alright, what about number 7? Is 4096 on the chart? Okay, it's 4 to the 6th power. So once again, when we ask ourselves the question, starting with the base, and we say that base to the what power is going to give us this other number. We just saw that that was 6. Alright, 4 to the 6th power is 4096. Alright, here again, looking at number 8. When we look at this and we ask ourselves, okay, 27 to the what power is equal to 3? Well, as soon as we see that we have a big number becoming a smaller number, you should be thinking, alright, this is going to be like a root. It's going to be a fractional power. Is this square root or cube root or fourth root? Well, see here, there's my 27. So the third root of 27 is 3. In other words, okay, maybe I'll do this off to the side. Because the third root of 27 equals 3, we know that the third root is the same thing as the 1/3 power. Okay, so we know that 27 to the 1/3 power is equal to 3. Okay, so 1/3 has to be the answer. Alright, so when it's turning a big number into a smaller number, it's probably going to be 1/2 or 1/3 or 1/4, because it's going to be either square root or third root or fourth root or fifth root or sixth root. Anyway, looking at this one, again, one way to do this is to sort of ignore the 1 for a minute and start by asking yourself, okay, 4 to what power is going to give me 64? Alright, that turns out to be 3. 4 to the third power is 64. Okay, so that would make the answer be 3. But it wasn't 4. It was 1/4. Alright, because it's 1/4, we would need this to be -3 in order to do the reciprocal of this and make it into a 64. Alright, so -3 is the answer. Alright, this one, normally I'd say, okay, 343 to what power is equal to 16,807? But clearly, 343 is not one of my bases. It only goes up to 10. So instead, we need to find both of these numbers in the same row so we can rewrite them with the same base. So let's look for 343 and 16,807 in the same row. Okay, they both are in the row 7. Alright, so 7 to the third power and 7 to the 5th power. Okay, so that means okay, 7 to the third power, and then I'm just going to put that x for the unknown, and then this is 7 to the 5th power. Okay, in this form, logic tells us that these exponents must be the same. If the bases are the same, the powers are the same. So that means 3x must equal 5, And if you divide both sides by that 3, that'll get x by itself. Okay, so x is equal to 5 over 3. Now there wasn't really an x, I just am using the x instead of a question mark just to represent the unknown. That's what a variable is. So the answer is just 5 over 3. Okay, that's number 10. Guys, please make sure you do not have a pencil in your hand right now. Do not copy off of me. If you don't know how to do a problem, watch me, learn how to do it, but then go back and do the problem yourself. Okay, condensing expressions. So we're going to be using our properties of logarithms. And condensing means we're going to go from this form to this form. Okay? Now, for this problem, you see the minuses and the plus. That means we're going to be using a combination of the product property and the quotient property. Alright, so an easy way to look at this is any term here that's positive is going to give us a factor in the numerator. So this is positive and this is positive. So I'm going to have a 7 and a 6 up top in the numerator. Okay, now on the other hand, this term is negative and this term is negative. So these terms are going to contribute factors to the denominator. But wait a minute. First of all, we have to use the power property. If you see a coefficient like c, it's got to end up back as a power. So really, before I do this part, this 4 is going to come over here and become 4th power. This 3 is going to come over and become 3rd power. Okay, so I'm going to have natural log 7 minus natural log x to the 4th minus natural log y to the 3rd plus natural log 6. Now, like I was saying, numerator, numerator, denominator, denominator. Alright, positive, positive, negative, negative. So that means this will condense to natural log of, in the numerator, I've got 7 times 6. Alright, in the denominator, I've got x to the 4th, y to the 3rd. Now, if these were variables, I'd be done. But since I can do 7 times 6, let's go ahead and do it. So this will be 42 over x to the 4th, y to the 3rd. Alright, that's it for number 11. Alright, we're really going to do the same thing for this problem. Meaning the first thing we do is we'll take these coefficients and make them powers again. Now don't forget, 1/3 power is really the same thing as the cube root. So watch out for that. Okay, so I'm going to have log base 6 of k to the 4th power minus log base 6 of p to the 1/3 power, but like I said, p to the 1/3 power is the cube root of 3. So let me just leave myself a little bit more space so I can do the cube root of p like I'm supposed to. Now, just like I did before, anything that's positive is going to wind up contributing to the numerator. So this is a positive term, so I will have k to the 4th in the numerator. This being a negative term will give me cube root of p in the denominator. Alright, that's why the final answer is log base 6 of k to the fourth power over the cube root of p. Okay. Please make sure when you make these bases that you put them low. If you write this, see log base 6k to the fourth, if you write log 6k to the fourth, where it looks like this is all on the same line, I'm going to mark this wrong. Okay? This 6 cannot be all big like this, as big as a k. That 6 needs to hang low, because it is a subscript. Alright, number 13. First of all, when we're expanding, we need to deal with this square root business. So please understand, and I'm just going to do this off to the side in green like you do. If I have the square root of 7y, that's the same thing as 7 to the 1/2 power y to the 1/2 power. So before we even begin the problem, let's rewrite it like this. So we will have log x to the fourth power 7 to the 1/2 power y to the 1/2 power. That's important because this way we have our three separate things, and we have these powers that we can use the power rule to put them in the front. Alright, so we have three things all multiplied together. So we can use the the product rule to turn this into a sum. But it will be a sum of 3 logs. So this will become log x to the fourth power plus log 7 to the 1/2 power plus log y to the 1/2 power. Now all these powers are going to end up as coefficients in the front, according to the power rule. So that's why the final answer will be 4 log x plus 1/2 log 7 plus 1/2 log y. That will be your final answer. Alright. Now, see this quotient, but I encourage you to look at this as 3 things. Let me color coordinate it a little bit. We've got one thing here in the numerator. So when I expand, alright, because I'm about to use a combination of your product rule and your quotient rule. But the thing is, anything in the numerator is going to end up positive. Anything in the denominator is going to end up negative when we expand. See, like both of these in the product property, both of these are in the numerator. So that's why they both end up positive. Okay, so observe. So I've got that 5 in the numerator, but then I've got these 2 things in the denominator. So this green thing's going to be positive, and these 2 purple ones will be negative. If you look at it that way, you can do it all in one shot. Maybe I'll keep the colors going. So on the next step, we're going to have natural log 5. Alright, that's positive, numerator. But then we will have minus natural log 6. Okay, that's a purple guy. And then minus natural log p to the 4th power. Alright, green, purple, purple. Positive, negative, negative. Numerator, denominator, denominator. You get it. That's the quickest way to do this. And then if you have any exponents, like this 4, just put that as a coefficient, and you're done. So that's why the final answer will be natural log 5 minus natural log 6 minus 4 natural log p. Alright, so that's number 14. Okay, number 15. Alright, so these are those ones where we're given certain facts and we need to rewrite the problem using these facts. So just to be, let's highlight. So we want everything in terms of 2 and 3 and 7. So 2, 3, and 7 are great to use. So let's see, 243. That's a big number. Let's see if that's on our chart and if it involves a 2, 3, or 7. Alright, 243. Boom. 243, and I see that that is 3 to the 5th power. Okay, 243 is 3 to the 5th power. So that means what I have here is log base 5 of 3 to the 5th power. Now, using the power rule, this 5 can come out front. So that means this is going to be the same thing as having 5 times the log base 5 of 3. Okay, now log base 5 of 3, that's one of our facts. So this is the same thing as 5 times 0.683. Alright, and though we will not be allowed to use a TI-30XS multi-view, we can use our bootleg 4-function calculator, which I'm going to do right now. So this would be 5 times 0.683, and that will be 3.415. Okay, so that's number 15. Alright, number 16. Now, we're allowed to use 2s and 3s and 7s. So the 2 is good. And now the 21 is 3 times 7. So in other words, this is the same thing as having log base 5 of 3 times 7 over 2. So remember how we did the last problem. We could expand this using a combination of the product rule and the quotient rule. We can do it in one step if we realize that anything in the numerator is going to give us a positive term, and anything in the denominator will give us a negative term. Okay, so this is going to be positive, positive, and negative. So this would be the same thing as having, alright, log base 5 of 3, positive, and then this one will also be positive, so log base 5 of 7. Now this one in the denominator will be negative, so negative log base 5 of 2. Okay, that allows us to do it all in one shot. Now all three of these things are things that were given. Log base 5 of 3 is our 0.683. Log base 5 of 7 is our 1.209. And finally, log base 5 of 2 is 0.431. And we can add these up using our 4-function bootleg calculator. So 0.683 plus 1.209 equals, and then minus 0.431. So the final answer is 1.461. Okay, genius. Alright, number 17. Okay, 18. Now remember, we're looking for 2s and 3s and 7s. So over here off to the side in green, I'm going to do sort of a factor tree of 18, but I'm shooting for either 2s, 3s, or 7s. Now 18 I know is 2 times 9. Now I like the 2, so I'm going to keep that. Okay, now of course 9 is 3 times 3. Okay, so if I think of 18 as 2 times 3 times 3, then I have all facts that I am given. So I can think of this as log base 5 of 2 times 3 times 3. So then this will expand as log base 5 of 2 plus log base 5 of 3 plus log base 5 of 3. Okay, this is a little bit the long way, okay? A slightly easier thing to do, or just slightly quicker, and I'm mostly thinking of, I mean, this would have been fine, but what if this had been, you know, like 9 is the same thing as 3 squared, right? And so wouldn't it be easier to just do 3 squared? Okay, and in this particular problem, it wouldn't have made a big deal, 3 squared, instead of just writing it twice. But what if this had been something like 3 to the 5th power? You don't want to have to sit here and write it out 5 times. You just want to put the 5th power. Now this power, of course, is going to wind up going in front according to the power rule. Okay, so really we will have log base 5 of 2 plus 2 times the log base 5 of 3. Now if you do it the other way, you should get the same answer as me. Alright, because obviously 2 times something is the same thing as adding it up. It's no different. Anyway, log base 5 of 2, we know that that is 0.431. And log base 5 of 3 is 0.683. Okay. Okay, so this will be plus, let's see, 1.366. And adding these up, I'm getting, let's see, maybe I'll put this over here. I'm getting 1.797. Okay. That is number 17. Alright, let's find number 18. Not over here, not over here. Okay. Alright. Alright, just a few more questions. Alright, so finding the value of these variables. For most of these problems, my recommendation is going to be try writing the problem in the other form. Like this is log form, so I'm going to be writing these in exponent form. So starting with the base, so in this case the base is p. So this would be the same thing as p, alright, and then these two things basically switch places. So I will have p to the negative 3 power is equal to 512. So this new exponential form is equivalent to the form I had before. Okay, so now how do I solve this? Well, if I want to get p by itself, I need to get rid of this power. And the way you can get rid of a power is to multiply by the reciprocal power. Now, so this is negative 3 over 1. Okay, so if I do this to a power of negative 1 over 3, then I'm golden. Alright, those are going to cancel out. But you know what, before I do that, let's go ahead and convert this 512 over. Alright, 512, I bet that's on the chart somewhere. Alright, there it is. 8 to the third power is 512. So this is the same thing as having, alright, p to the negative 3 power is equal to 8 to the third power. Alright, so now, like I said, if I raise this to the negative 1/3 power, and I raise this to the negative 1/3 power, I'm allowed to do the same power on both sides if I want to. But these are going to cancel each other out because I did the reciprocal. So they will always cancel out. Because this is like having 3 over 1. So these 3's cancel and the 1's cancel, and a negative times a negative is a positive. So if you do the reciprocal power, that's just going to leave p. Now over here, I'm just going to have 8 to the negative 1 power, because basically these 3's are going to cancel out. Now, if you're having any trouble seeing why it's negative 1, I'm going to show you the long way. This 3 is like having 3 over 1. So basically we have 3 over 1 times excuse me, negative 1 over 3. Okay, so that's going to give us negative 3 over 3, which is negative 1. Alright, so that's where this negative 1 is coming from. Alright, but when I look at it, I just go, oh, these 3's are going to cancel out, and that's just going to leave negative 1. It's quicker. But you have to have the sight, the gift of sight. Some of y'all don't have it yet. Anyway, so this is practically the final answer, but we're not allowed to leave the answer with any negative exponent. So we will go ahead and write this as p to the 1/8. I mean, p equals 1/8. Okay, so we solved it. Now, number 19. Let's do the same thing. Let's write this in the other form. Now, this is the base. So always start with the base. So that means 1 over 3,125. That base. Okay, now these two guys are going to switch places, basically. So I'm going to have negative 2/5 power equals that x. Okay, now x is by itself, so all I have to do is simplify this. Now remember, if you have a fraction with a negative power, the easiest thing to do is do the reciprocal and make it positive, remember? So this would be the same thing as having 3,125 to the 2/5 power. Okay, because this is the reciprocal of this. Now remember this. When you have a fractional exponent, what you're looking at is a power over the root. Alright, this is the power and this is the root. So 5th root, focus on that. So that means what we're really dealing with here is the 5th root of 3,125. And then whatever we get for that, we're going to do the second power to it. So that's what's happening. So let's use our chart. 5th root of 3,125. So 5th root of 3,125 is 5. That means in here what we really have is 5. So then this is 5. But then it's 5 squared. We don't need our chart for that. So that is 25. Okay, that is it. Alright, so I think this is going to be the last problem. So number 20. So one more time, writing this in exponent form, start with the base. So I'm just going to bring this down. So I've got 1,024. And these basically switch places. So I'm going to have the nth power is equal to 4. So in other words, 1024 to what power gives you 4? Well, I see that I have a big number becoming a smaller number. So I'm thinking this is really going to be some kind of a root. Okay, some kind of a root. Like what root is going to turn 1024 into 4? Okay, let's see. 1024 into 4. Alright, look, it looks like it would be the fifth root. The fifth root of 1024 is 4. Okay, I should be doing this in green off to the side here. Okay, because this is like my thought process. So it turns out that the fifth root of 1024 is 4. But we know that the fifth root is the same thing as the 1/5 power. Okay, so this is our thought process. Alright, it's going to bug me if this is not green also. Hold on. Alright, that's better. OCD. So, back to this. So we were asking ourselves, 1024 to what power would make 4? But you should have been thinking, oh, this is really going to be one of those roots. We looked at the chart, and it turned out that the fifth root will change it into a 4. But the fifth root is the same thing as 1/5 power, so that lets us know that the final answer is 1/5. Alright, 1/5 is the power that changes this into this, and is 1/5. Okay, that is it. Please make sure you can do every single problem on this paper on your own. You know, if you were struggling and you're watching this video, then you know, that means there were problems that you didn't really understand. And maybe you understand it now that you watched me do it, but that's not the same as doing it yourself. So please go back and redo problems by yourself. Make sure you can do every single problem, you know, on your own, like, you know, tonight or something. If you can do this practice quiz, you know, quiz C, from start to finish, without cheating, you know, without watching any videos or looking at your notes, that's how you'll know that you're ready for this quiz. Alright, peace out. I will see you on the next video.